Welcome to Do the Math America. I am Charlene Math Shaman. This is lesson 60, volume and surface area of prism and cylinder, from pages 352 through 359 of the New Elementary Mathematics Syllabus D textbook. Please look in the description box below this video for the link to where you can find a copy of this textbook, or you can go to singaporemath.com. These two figures are solids. Which one occupies more space? It's difficult to answer unless you have made some measurements. If two solids occupy the same amount of space, we say that the solids have the same volume. Volume is described as how much space a three-dimensional figure occupies. In this video, we will explore how to measure volume. You will be able to determine which of these two figures has a larger volume. To measure volume, we must have a volume unit. In the top right figure, we have a cube, which has a length of 1 centimeter, a width of 1 centimeter, and a height of 1 centimeter. We call this unit 1 cubic centimeter. It is a unit of measurement in the metric system. 1 cubic centimeter also equals 1 milliliter. So in the metric system, we have an easy conversion from measurement of distance, centimeters, to a measurement of volume, milliliters. The English Standard System, in contrast, does not have an easy conversion from distance to volume, which is one reason why the scientific world has adopted the metric system. A larger unit of measurement, 1 cubic meter, equals 1,000 liters. A cubic meter would be a cube that has a length, width, and height of 1 meter each. In the English Standard System, we could use 1 cubic inch, 1 cubic foot, or 1 cubic yard for measurement. However, there is not an easy conversion from this measurement of distance to measurement of volume in the English Standard System. For example, 1 cubic yard equals 173.56 dry gallons, or 201.976 liquid gallon. The larger cubic figure on this page has a length of 3 centimeters, a width of 2 centimeters, and a height of 4 centimeters. You multiply 3 centimeters times 2 centimeters times 4 centimeters to get 24 cubic centimeters, which is its volume. So the formula for measuring a volume of a cube is length times width times height. Please make note that we also multiply the units, centimeters times centimeters times centimeter, to get cubic centimeter. So just to reiterate, the volume of a cuboid is length times width times height. And if you recall, the area of a rectangle is length times width. So you can think of it as the area of the rectangle, or area of the base times height. The figure on top is a solid and is a prism. If any cut is made through it horizontally, the surface exposed to view is always of the same size and shape. This surface is called the cross-section of the solid. And the solid is said to be of uniform cross-section. Notice that the area of the cross-section is the same as the area of the base. In this case, the base is a trapezium. The base area can be cut and rearranged to form a rectangle, as shown. we see that the prism itself can be cut and rearranged to form a cuboid. Thus, the formula for volume of a prism can be written as volume of prism equals area of base times height, or volume of prism equals area of cross-section times height. The formula for the volume of prisms applies to all types of prisms, including some of these as shown. And once again, the volume of prism equals area of base times height, or the area of the cross-section times height. The figure on the top left is a cuboid, which is also known as a rectangular prism. The top middle figure is a triangular prism. And the total surface area of any prism is the sum of the area of all the faces. The formula for the volume of prism equals the area of the base times height, or the area of the cross-section times height, applies only to a right prism, as shown on the left-handed figure, and not to an oblique prism, as shown on the right-handed figure. A right prism is one in which the center of the top face is directly above the center of the base. If you bend a rectangular sheet of paper to bring a pair of opposite edges together, you will get an open tube like the one shown. This is called an open cylinder. The surface area of this open cylinder is the area of its curved surface given by the product of the distance around the rim and the height. And in this case, you can see that the distance around the rim would be the circumference of the circle, which would be given by the formula 2 pi r. And you multiply that with the height to get the surface area of the open cylinder. So that would be 2 pi r times height, or the length of the cylinder. If the two ends of the cylinder are covered, it is called a closed cylinder. So we have the surface area of the closed cylinder equals the area of the curved surface plus twice the base area, because there is a top face and a bottom face to this cylinder. A cylinder can be divided into many parts and rearranged to form a cuboid as shown. It is reasonable to assume that the volume of the cylinder equals area of base times height. In general, for a solid cylinder with a radius of r units and height of h units, we have the volume of the cylinder equals pi r square, or the area of the circle, times h, or height. The surface area of this cylinder equals 2 pi r times h plus 2 times pi r square, or the area of the base and area of the top. So the surface area equals 2 pi r times h plus 2 times pi r square, which can be simplified as 2 pi r, open parenthesis, h plus r, close parenthesis. And if you recall, 2 pi r is the circumference of a circle, and pi r square is the area of a circle. And you multiply pi r squared times 2 to account for the top and the base of the closed cylinder. This rather long formula, 2 pi r times h plus 2 times pi r squared, can be simplified by pulling out the like factors So if we multiply all the variables together, removing the times symbol x and just writing the variables adjacent to each other to indicate multiplication, then we get 2 pi rh plus 2 pi r squared. Now we can see more clearly from the variable expression that 2 pi r are the like factors, leaving h plus r as the independent expression to be isolated within the parenthesis. Since this is the first time we've worked with multivariable expressions in my video lesson series, this equation might look intimidating and confusing at first. So I will rewrite and break down that algebraic expression so that you can see more clearly what we are doing. So this equation can be rewritten as 2 pi rh plus 2 pi r times r in place of r squared. Now you can see more clearly that 2 pi r are the like factors to multiply h plus r within the parenthesis. Can help to remember how the distributive property works for algebraic expressions by using more simple variables. So for example, the algebraic expression 2x plus 2y has a common factor of 2. And we can pull out that 2 in front of x plus y, which we leave in the parenthesis. And that is the equivalent action to what we did below with 2 pi r times h plus r within the parenthesis. The volume of a rectangular solid is 576 cubic centimeters. It is 12 centimeters long and 6 centimeters wide. Find its height. So I begin by drawing a picture of a rectangular solid or prism and label the sides with the appropriate lengths as given. So I write down the facts of the problem to begin with. Volume equals 576 cubic centimeters, and I draw out the length to be 12 centimeters long and the width of the solid as 6 centimeters wide. Next, I write down the formula for volume of a cuboid or rectangular solid as length times width times height. Now it's just a matter of plugging and chugging the correct values in for the equation. So the volume is 576 cubic centimeters, which equals the length, which is 12 centimeters, times the width, which is 6 centimeters, and that just leaves the height as the unknown. So I start by multiplying 12 centimeters times 6 centimeters, and I do that equation on the side. 12 times 6 equals 72, and I write 72 on the line below, and I also write centimeter square for centimeter times centimeter. Always include your units in your calculations. Times height equals 576 centimeters cubed. Now I'm ready for the next step of this problem, which is to divide both sides of the equation with 72 centimeters square in order to isolate height by itself on the right-hand side of the equation. On the right-hand side of the equations, 72 centimeters square cancels with 72 centimeters square in the denominator, leaving height by itself. And on the left-hand side of the equation, I have 576 divided by 72. And I do that calculation on the side. And I start by finding the multiples of 72. Doing these calculations by hand and double checking my work as I go helps me keep my mind sharp and focused on the problem, and also reinforces the math facts in my memory bank so that I have instant recall of these facts when I need them. If you don't use it, you lose it. So you have to reinforce your skills as you learn math. And now I see that 72 times 8 equals 576. So 576 divided by 72 equals 8. I write 8 on the line below the problem, and then I must divide centimeters cubed divided by centimeters square to get centimeters by itself. So the height of this rectangular solid is 8 centimeters, and I box my answer. The figure shows a rectangular prism whose length, breadth, and height are given. Find the surface area of the figure. So the area of a rectangle is given by the formula length times width. In this problem, breadth is used in place of width. So I will start by figuring out the area of the top and bottom rectangles, which are both 5 centimeters by 4 centimeters. And since that is two rectangles of the same dimensions, I have 2 times length times width, or breadth as the problem calls it. And I rewrite that on the next line as 2 times 5 centimeters times 4 centimeters. Starting from left to right, I have 2 times 5, which equals 10, times 4. And that would be 10 times 4, which is 40. And centimeter times centimeter would be centimeters square. So the area of the top and the bottom rectangles are 40 centimeters square. Next, I will figure out the area of the 4 vertical sides of the rectangular prism. And I see I've misspelled vertical. It should be vertical. In any case, the area of the 4 vertical sides would be 2 times 6 centimeters times 4 centimeters plus 2 times 6 centimeters times 5 centimeters. Since 2 of those vertical panels are 6 by 5 and 2 are 6 by 4. According to order of operations, we multiply first from left to right before we do addition. So I start with 2 times 6, which equals 12, times 4. And I do that calculation on the side. 12 times 4 equals 48. And I write 48 on the line below. And centimeters times centimeters equals centimeters square. And I continue the problem by including the addition sign. Next, 2 times 6 equals 12. 12 times 5, I do that calculation on the side. 12 times 5 equals 60. So I write 60 on the line below. Centimeter times centimeter is centimeter square. Now I have 48 centimeters square plus 60 centimeters square. And I do that addition, 48 plus 60, on the side. 48 plus 60 equals 108. And since I am just adding the units this time, not multiplying, I just add the numbers and keep the same unit of measurement, centimeters square. So the area of the 4 vertical sides is 108 centimeters square. And now I just need to add the area of the top and bottom panels plus the area of the 4 vertical sides to get the total surface area of the figure. So the final calculation would be 40 centimeters square plus 108 centimeters square. And I write that on the line below, 40 centimeters square plus 108 centimeters square. I do that calculation on the side. 108 plus 40 equals 148. So I write that on the line below, 148 centimeters square would be the total surface area of the figure, and I box my answer. Please make note that when you're multiplying units of measurements, you must also multiply the units. However, when you are adding units of measurements, you simply need to add the numbers and keep the same unit of measurement. Express A, 106.5 cubic centimeters in cubic meters. So I write A, 106.5 cubic centimeters in cubic meters to begin the problem. And I recall that 1 meters equals 100 centimeters. Since this problem starts with cubic centimeter and ends in cubic meter, I begin by making the conversion unit from a single centimeter unit. And I do so by dividing both sides of the equation with 100. On the right-hand side, 100 centimeter divided by 100 equals 1 centimeter. And on the left-hand side, 1 meter divided by 100. Dividing by 100 means I move that decimal point 2 places or 2 scoops to the left, fill in that scoop with the 0, put a 0 in front of the decimal point to get 0.01 meters. So 1 centimeter equals 0.01 meters. Now we can break down 106.5 cubic centimeters. 106.5 cubic centimeters equals 106.5 centimeters times 1 centimeter times 1 centimeter. And we can verify by multiplying centimeter times centimeter times centimeter the units, which equals cubic centimeters. And on the side, I work out that 1 centimeter equals 0.01 meters. So therefore, 106.5 centimeters equals 106.5 times 0.01 meters. 106.5 times 0.01, move that decimal point between 6 and 5 2 scoops to the left, which gives me 1.065 meters. And back to the problem on the line below, I substitute 1.065 meters underneath 106.5 centimeters. And I multiply that with 0.01 meters as a substitute for 1 centimeter and 0.01 meter for the substitute for the other centimeter. Multiplication adheres to the commutative property, meaning it doesn't matter which factor I multiply first, so I will first multiply 0.01 times 0.01. I add up all the decimal points or decimal places, and I move the decimal point 4 scoops to the left, filling those empty scoops with 0. So I get 0.01 times 0.01 equals 0.0001 meters square, because we also multiply the units. And I multiply that with 1.065 meters to continue the problem. 1.065 times 0.0001, I do that calculation on the side. 1 times 1065 equals 1065, And now I just need to add the decimal places from both factors. I have 3 decimal places from the first factor and 4 from the second for a total of 7 decimal places. So I bring that decimal point 7 scoops to the left, fill out those empty scoops with zeros to get 0.000165. And I write that underneath the problem, making sure not to leave out any zeros. So it's 0.000165 meters cubed. Because I also must multiply meters squared times meters. So 106.5 centimeter cube, or cubic centimeters, equals 0.0001065 meters cubed. I box my answer. Express B, 3.6 cubic meters in cubic centimeters. 1 meter equals 100 centimeters. 3.6 cubic meters equals 3.6 meters times 1 meter times 1 meter. Since 1 meter equals 100 centimeters, then 3.6 meters equals 360 centimeters. That is, I move the decimal point 2 scoops to the right to get 360 centimeters as a substitute for 3.6 meters, and substitute 100 centimeters for the 1 meters above. Multiply 360 times 100. I add 2 more zeros to 360 to get 36,000. Centimeter times centimeter equals centimeter square. And then I multiply by 100 centimeter to continue the problem. To multiply 36,000 times 100, we add 2 zeros to 36,000, which gives us 3,600,000. Centimeter squared times centimeter equals cubic centimeters. So 3.6 cubic meters equals 3,600,000 cubic centimeters. And we box our answer. Express C, 12,780 cubic millimeter in cubic centimeter. And we recall 1 meters equals 100 centimeters, which equals 1,000 millimeters. Since this problem asks us to convert cubic millimeters to cubic centimeters, I will focus on the relationship between centimeters and millimeters. So 1 centimeter equals 10 millimeters, because if we divide 100 centimeters by 100, we get 1 centimeter, and when we divide 1,000 millimeters by 100, we get 10 millimeters. 1 millimeter equals 0.1 centimeters, because we move that decimal point over to the left 1 decimal place. That is, 1 millimeter equals 0.1 centimeters. Since this problem starts with cubic millimeters and ends in cubic centimeters, we begin by putting the initial unit, cubic millimeters, in its singular form, that is 1 millimeter relative to centimeter, the ending unit. 1 millimeter equals 1/10 centimeter. Now we're ready to break down 12,780 cubic millimeters into individual units. So 12,780 cubic millimeters equals 12,780 millimeters times 1 millimeter times 1 millimeter. When we look at the units, millimeter times millimeter times millimeter equals cubic millimeter. Now we can substitute the unit equivalent to centimeter to make the conversion from millimeter to centimeter. So 12,780 millimeters equals 12,780 divided by 10 centimeters, because we need to move that decimal point 1 decimal place to the left to convert millimeters to centimeters. 1 millimeters equals 0.1 centimeters, and 1 millimeter equals 0.1 centimeters. So now we've substituted the equivalent of centimeters with millimeters to do the conversion to cubic millimeters. I'm multiplying 0.1 times 0.1 to get 0.01 centimeters square. And I write that on the line below, 0.01 centimeters square, because I also must multiply the units. And I multiply that with 1,278 centimeters to continue the problem. So 1,278 times 0.01, I take the decimal point behind 8 and move it 2 places to the left to get 12.78. And I multiply centimeter times centimeter squared to get centimeters cubed, or cubic centimeter. 12,780 cubic millimeters equals 12.78 cubic centimeters. And I box my answer. A solid cylinder has an altitude of 15 centimeters and a base of radius 7 centimeters. Find A, the volume, and B, the total surface area of the cylinder. Take pi equals 22/7. So once again, I begin by drawing a picture of the cylinder to get an idea of what is the problem that needs to be solved and how to approach the problem. I label the figure with the facts given. In this case, there is an altitude or height of 15 centimeters and a radius of 7 centimeters. I start by solving for the volume of the cylinder. The formula for volume of a cylinder is area of the base times height. The base in this case is a circle, so it would be the area of that circle, pi r squared, times height, or altitude. And now we just need to plug in the values given to solve for volume. So pi is 22/7 times r, which is radius of 7 centimeters, and we need to square that, times height, which is the altitude, or 15 centimeters. I will rewrite this equation on the next line as 22/7 times 7 centimeters times 7 centimeters times 15 centimeters. So you can see how I can eliminate the 7 from the denominator with one of the 7's in the numerator, which leaves me with 22 times 7 times 15 and centimeters cubed from the 3 centimeters being multiplied together. Now I just need to do some multiplication on the side. 22 times 7, which is 154, which leaves me with my final calculation, 154 times 15, which I also do on the side. 154 times 15 works out to be 2,310. I write 2,310 on the line below the problem. With cubic centimeters, always include the units in your calculation. So the volume of the cylinder is 2,310 cubic centimeters, and I box my answer. Next, I will find B, the total surface area of the cylinder. The total surface area of the cylinder would be the area of the side of the cylinder plus the area of the top of the cylinder plus the area of the bottom of the cylinder. The area of the side of the cylinder would be the distance around the rim, which is the circumference of the rim, 2 pi r, times height. So I start by writing the equation 2 pi r times height, and I will plug in the values given. So r, the radius, is 7 centimeters, and the height, or the altitude, is 15 centimeters. The top and the bottom area of the cylinder are both pi r square, and since they are both the same area, I will make that 2 times pi r square. Now I will plug in the values for the equation. The slash altitude is not a divide by altitude, it's just to clarify that height means altitude. So in the next line, I write 2 times pi, which is 22/7, times 7 centimeters for the radius, times 15 centimeters for the height, plus 2 times pi, which is 22/7, times radius, which is 7 centimeters square. But instead of writing 7 centimeters square, I will write it as 7 centimeters times 7 centimeters. Now I begin simplifying the problem by canceling the 7 in the denominator with the 7 in the numerator, which leaves me with 2 times 22 times 15 centimeters square, because I have centimeters times centimeters, plus, and then on the next part of the equation, I also cancel the 7 in the denominator with the 7 in the numerator, which leaves me with 2 times 22 times 7 centimeters square from multiplying centimeter times centimeter. Now I continue to simplify the equation on the next line. 2 times 22 equals 44. So I have 44 times 15 centimeters square, plus, again, 2 times 22 equals 44 times 7 centimeters square. I continue to simplify. I have 44 times 15, which I do that calculation on the side. 44 times 15 works out to be 660. I write that on the next line. 660 centimeters square plus 44 times 7, and I do that calculation on the side. 44 times 7 equals 308. So now I have 660 centimeters square plus 308 centimeters square. Since those both have the same units, centimeters square, I can just add them together. 660 plus 308 equals 968 centimeters square. So the total surface area of the cylinder is 968 centimeters square, and I box my answer. The exercises for this lesson are found on pages 357 through 359 of the textbook. As you can see, these problems are rather involved, and you can expect to take some time to wrestle through each one of them. In learning math, practice makes perfect. So, I encourage you to work through all the problems presented here, and please check your answers with those in the back of the book on page 436 to make sure you did the problems correctly. If you need more help solving these problems, you may consider purchasing a copy of the Solutions Manual in addition to the textbook. I have included a link to these books in the description box below this video. And here I am scanning the pages of this textbook in which I have used to make this video. Sometimes it helps to study the textbook itself when you are learning math concepts. Perhaps you can see that I have simply animated the lesson of this textbook in this video. And just please keep in mind that when you are multiplying units of measurements, you also must multiply the units. However, when you are adding the units of measurement, then you just add the numbers and then keep the same unit of measurement. I hope this video was helpful to you. And if it was, please give me a thumbs up, subscribe to my channel, and please share this channel with anyone you know who wants to learn math. Thank you for joining me at Do the Math America.